Alrighty then, this is part 3 of chapter 7 on energy, and this is going to be all about different energy policies and prices and output. Now, one assumption here is that energy sources are largely interchangeable, but at what price and level shall we set for energy use? Now, one assumption in these next couple 3 slides is that we have accounted for social costs and we have internalized the externality. So when you see the cost in this case, it will be the social cost, not necessarily the private cost, especially in our first graph. We'll look at the situation given price controls. What will the outcome be given the market structure? I think he'll compare monopoly to competition. What are some outcomes when we have price discrimination? What happens when we deregulate certain energy markets? What are some of the perverse things that may happen? Might things actually become more expensive if you deregulate? What role does politics have in this whole drama? And it certainly does have a role. And finally, a discussion of cafe standards, which is not going to a cafe, but fuel economy standards and emissions gaps. Okay, so here is the energy market and representative components. So we have solar, oil, and coal, and then we have the energy market. So what it's saying here is, given that we're talking about private markets here, you at a given price, you can sum up the quantities, and that would give you the market at a given price. Your author gives an example. If 20 cents were the marginal social cost for the 2 billionth kilowatt of electricity, the 1 billionth kilowatt from oil, and the 0.5 billionth kilowatt from coal, then the horizontal sum would be 3.5 billion kilowatt at 20 cents. You produce the energy until the marginal benefit exactly equals the marginal cost, keeping in mind that the benefit will be decreasing marginal returns, and of course the cost from extraction would go up. You, especially in the case of oil and coal, you go for the easy extraction first, but then you'll be spending more money with harder to find resources for that. Now there are gains from switching. So here we have an example of oil and coal, and let's say we produce we produce more solar, so our marginal cost shifts. We add more solar panels and the like, and at the same time we switch away from coal. And so, in the case of solar, there are positive externalities. In the case of coal, there are negative externalities. If you look at area B, we are subtracting B and we're adding A. And as we do that, we gain the area of B minus A. So the net benefit to society of equating the dollars per kilowatt of solar and coal energy is B minus A. Okay, now we look at price ceilings. So the government could get involved in setting a price ceiling. Remember that a price ceiling is, you cannot go above the ceiling. So it is the highest possible price that can be charged. Now we have a first case of a competitive market. And when you have a competitive market and the price ceiling is below the equilibrium, then that price ceiling is binding, meaning that it has an effect. And indeed, you do have a shortage. Our quantity demand is certainly greater than our quantity supplied at the price ceiling price. Our second case is a monopoly. If we set the price ceiling at prices equal to marginal costs, we might actually result in a more efficient outcome. You actually might have more being produced relative to a monopoly. But in this case, you may actually want to see the monopoly because that would be less of the energy source being produced and less pollution as a result. Now, our third case is a natural monopoly, and this is a price ceiling set at price equal to average cost. It can lead to normal rates of return and perhaps a more efficient outcome. Very hard to set prices at equal to marginal cost, so actually when regulation takes place, the ceiling is set at price equal to average cost because that is something that can be indeed measured. So the attempt by government to set the price can result in radically different outcomes depending upon the market structure that we're talking about. Now, another option is price discrimination. Different consumers are paying different prices for the same good. Different people have different willingnesses to pay, and if you have a relatively high willingness to pay, but you're getting a low price, you have a lot of consumer surplus. So if you're willing to pay P1, as you can see there, but our price is P4, you get that whole area as consumer surplus. But what if the producer could charge different prices to those different customers? The outcome would be efficient if externalities are absent or externalized. So charging different prices. Now, perfect price discrimination would be where utilities would maximize profits by producing where basically charging a different price to every person. It's seldom possible to have perfect price discrimination, but you can have something called peak load pricing, where at the more busy times you charge a higher price relative to less busy times. This is very unpopular as one might imagine, but it is certainly something that's probably coming down the road, and it's a way to deal with traffic congestion as well. Many towns, not many, but some big cities either have it, like Singapore or London, or are considering it, like New York City. Okay, this section is about deregulation, and this is deregulation of utility companies. Remembering that utility companies, because they're a natural monopoly, are oftentimes regulated in terms of their price, recognizing that the high fixed costs generally lead to monopolized single firms offering utility services. Now, in 1935, the PUHCA, which was the 1935 Public Utility Holding Company Act, gave U.S. electric utilities a monopoly in their area, but prevented them from expanding into other regions. In 1975, the Energy Act repealed the PUHCA. And so the long-term effects of this deregulation are uncertain. The wisdom of energy deregulation is hotly contested, mainly because is the natural monopoly such that it should be a monopoly? And if you do deregulate it, would you not have just regular monopolies in there with unregulated pricing? There are different viewpoints of this. It's hotly contested. Some worry that rather than fostering competition, deregulation will defeat the purpose and allow the purpose of PUHCA and allow two utilities to be replaced by a deregulated electric company C that would dominate the market. Other folks feel like deregulation, like the Edison Electric Institute, because it's a trade association of investor-owned electric companies. The National Rural Electric Cooperative Association, feels that deregulation could have small effects on small-scale electric providers. So the viewpoints depend upon what perspective they're coming from. Now in California, in 2001, there was an experiment with deregulation, and unfortunately, that led to brownouts and extreme price spikes. And Enron in Houston basically took over the California utility market and charged enormously high prices because of that. So that's a cautionary tale for deregulation. And the economics of deregulation cannot be divorced from the politics. Parties on all sides of the energy deregulation debate have funded political activities either for or against deregulation. Now there are now one thing that can change things considerably is solar panels and individual homeowners. If there's lots of homeowners that have solar panels, that can disrupt the initial natural monopoly, because then they cannot offer their costs will go up and our costs would go up as consumers within the natural monopoly. Let's say HECO, and they cannot offer the average cost quite as low anymore. The cost cannot be spread out so much. And here is a picture of a cable car that is illustrating California's deregulation issue in the early 2000s. Okay, our next and final slide is going to be about the role of politics, and certainly that plays a major role with regard to energy, oil, and automobiles. Battle between big business, the auto companies, and the environment. And of concern is the possibility that political and financial forces may impede efficiency with the market of fuel, automobiles, and other goods that affect the environment. In other words, oil production may actually be subsidized, and that's where politics comes into play. When in reality, since it causes a negative externality, it really should be taxed. And this is due to much political lobbying that takes place in Washington and in state capitals around the nation. So misplaced subsidies. We in the United States have come up with CAFE standards, so fuel efficiency standards. Modern cars derive power from fuel combustion, but that combustion is less than efficient, and there are byproducts that occur. So the U.S. has tried to come up with fuel economy standards, but it's a long haul, and much political lobbying indeed takes place. Efficient fuel combustion would convert hydrogen and carbon into water and carbon dioxide. But it is less than efficient. And your book, in the last part of this chapter, has a timeline of the different activities with regard to having emissions cap, going from 1955 all the way through, let's see what the 5th edition has here, all the way through 2018 under the Trump administration. And with every president that comes in, there's either more or less government intervention for environmental concerns. Democrats tend to favor government intervention to increase the environment. Republicans, much less so. Okay, that's our timeline, and this finishes this chapter 7 on energy.